Alright, so here we are, another video. This is the refrigeration sheet metal exam that we typically give at the end of the week of training that you guys do. But instead I'm just going to go through the exam question by question and hopefully explain what each question means. So question number 1, the lowest pressure level within an air distribution system is found at the what? So I'm just going to show you guys an example of an air distribution system. If you watched the other video, it showed a very basic one, and this is a basic one again. So this cabinet right here would be the furnace, and in the bottom of the furnace they typically have a fan. So it's pulling in air from the return air and blowing it out the supply air side. So if you know or remember from elementary school science that air, like what causes wind, is differences in pressure. So high pressure is always going to go to low pressure. It's kind of like that hot going to cold. Like the room here is going to be at a lower pressure than the air in the ductwork here. So it's going to cause the air to go from the ductwork to the lower pressure system. On the return air side, because this side's sucking, the air pressure in the return air side is going to be lower. So at what point is the air pressure going to be the lowest? It's going to be right here at the intake of the fan. So when this fan turns on, it's causing a really huge negative pressure or a really low pressure zone. So air is going to be moving this way, and it creates a high pressure on the discharge end of the fan. So right there is the lowest pressure. Hopefully that makes sense. All right, question 2. The velocity pressure in an air duct equals the what? So I have to explain what they mean by velocity pressure. So if this is a piece of ductwork here, when you have air blowing into ductwork, the duct itself is going to be under the influence of a couple of different pressures. It's very similar to blowing up a balloon. When you blow up a balloon, it has a static pressure. So when you blow it up, it's putting pressure on all the sides of the balloon, so it inflates. But that pressure is not going anywhere. So it's just pushing outwards in the direction. So static pressure is an outward force on the ductwork. Because it's open on this end, the air, once it puts the pressure on it, some of that energy transfers into a velocity, so it starts moving down the ductwork, and that's a velocity pressure. So again, if I use that example of the balloon, if I blew up the balloon, that energy is just kind of sitting there. It's like potential energy, and if I was to release that balloon and it would shoot off across the room, what's coming out the end of the balloon is the velocity pressure, what's giving that balloon motion. So there's a thing in when we're doing calculations for ductwork, a total pressure, and a total pressure is simply the velocity or static pressure plus the velocity pressure is going to equal total pressure. There's a lot of complicated calculations that we end up doing for sizing ductwork or calculating the CFM or cubic feet per minute that goes through the ductwork. And knowing what these pressures are, we can end up calculating some of those some of the other information that we need. And this being a linear calculation, if static pressure plus velocity pressure equals total pressure, then total pressure minus velocity pressure will equal static pressure. So it works all over the place. Pretty basic math, but stuff you do need to know if you're a sheet metal worker. You guys don't really need to know that stuff for refrigeration, but it probably helps to understand it. Okay, moving on. Last time I asked this question, your whole class knew what it was. So at sea level, every inch of earth has an absolute pressure of 14.7 pounds per square inch. Now it's this question, if I had this on a test, it's kind of easy to tell what the answer is just by every inch, and the only one that is in per square inch. is that one. When I teach this to my class, I'm actually using inches of mercury. So it's 29.92 inches of mercury